Assalamualaikum warahmatullahi wabarakatuh, and hi students. So this is our new topics, that is the gaseous state. So now we are focusing on gases. Okay, this is the lesson outcomes for these topics. First, define the gas law. So we have for the gas law here: Boyle's law, Charles' law, Gay-Lussac's law, and Avogadro's law. So you need to know how to define these four gas law. Second, determine density and molar mass of the gas. So this one for the calculation of the density and molar mass. Determine the reaction stoichiometry involving gases. Find partial pressure using Dalton's law. So there is another law that is Dalton's law. So from this Dalton's law, you can find the partial pressure. Solve Graham's law of diffusion and effusion. And lastly, you should be able to interpret the deviation from ideal gas behavior. Okay, general properties of gases. Because this topic we are focusing on gas, so we need to know the general properties of gases. First properties is gases assume the volume and shape of their container. So gases have a volume and shape and of the container. Second, most compressible of the states of matter. So it can compress. Mix evenly and completely when confined to the same container. So it can mix evenly and completely in a closed container. Lower density than liquid and gases. So, one of the properties of this gases, it should be lower density. So, this is the unit of pressure of gases. Okay, so for pressure, so we know that pressure, the formula for the pressure is equal to force divided by area. So, you learn this one on physics. Okay, so this is the formula of pressure. And then, we know that force means that mass multiply with acceleration. Okay, so this is the formula. And then the unit for the pressure, you can use atmosphere, atm, millimeter mercury, mmHg, torr, kilopascal or bar. Okay, so there is a lot of unit for the pressure, and then this is the conversion unit. Okay, you need to know how to convert from one unit of the pressure to another unit of the pressure. For example, this one. So, we know that 1 standard pressure is equal to 1 atm. So, 1 atm is equal to 760 millimeter mercury. Okay. And then, 760 millimeter mercury is equal to 760 torr. 760 torr is equal to 101.325 kilopascal, and 100 kilopascal is equal to 1 bar. So this is all the unit for the pressure. So you need to know how to convert between bar to kilopascal, from torr to millimeter mercury. Okay, so all here are the conversion unit of the pressure. Okay, gas pressure. So when we put the gases inside the container, so there is a gas pressure. So gas pressure is caused by gas molecule inside the container bombarding a container's wall. So from the gas molecule bombard to the container, so it will form gas pressure. Okay, this is the conversion this is exercises for conversion unit of the pressure. Okay, you should try this exercise. Okay, I already give the hint here. So, you need to convert. For example, for the first one, the pressure outside a jet plane flying at high altitude falls considerably below standard atmospheric pressure. Therefore, the air inside the cabin must be pressurized to protect the passengers. So, what is the pressure in atmosphere in the cabin if the barometer reading is 688 millimeter mercury? So, given here is a pressure is 688 in millimeter mercury. So you need to convert into atmosphere. So I already give the hint here, the conversion factor here. So you need to convert. 1 atm equal to 760 millimeter mercury. The second one, okay, you can try this one. Okay, so you need to convert to kilopascal, this millimeter mercury. So you can try this one. So you can use this conversion. Okay. Okay, now we go to gas law. Gas law. So actually there is 4 types of gas law. First one is Boyle's law. Second is Charles' law. Third is Avogadro's law. And lastly is Dalton's law. So all here is a gas law. Variables that affect the properties of the gases. So here actually it's all the variables that affect the properties of the gases. That is pressure, volume, temperature, and number of mole. Okay, so all here for variables actually so it means that all the gas law, that is Boyle's law, Charles' law, Avogadro's law, Dalton's law, actually it depends on the all these variable. Okay, all these variable. Okay, now we go to the Boyle's law. Okay, what is Boyle's law? Boyle's law is the pressure of a fixed amount of gas at a constant temperature is inversely proportional to the volume of the gas. So here, so it means that we fix number of mole and temperature. Okay, this is the variables that we fix. And then there is another two variable, that is pressure and volume. So this pressure and volume actually is inversely proportional. Okay, so pressure is inversely proportional to the volume. So P is proportional to 1 over B. V. Okay, pressure is inversely proportional to volume. Because the definition is said that the pressure is a fixed amount of gas at constant temperature and number of mole is inversely proportional to the gas. So when you write in equal, okay, so you need to write volume here to the left. Bawakan ke kiri lah. So PV equal to K. Okay. So when you want to calculate using the Boyle's law, so the formula is P1V1 equal to P2V2. Okay, from here. Okay, because this one PV equal to K. So when you have 2 pressure and 2 volume, so you can calculate using this one. P1V1 equal to P2V2. Okay, from Boyle's law, we know that pressure is inversely proportional to volume. So it means that when we increase the pressure, volume will decrease. Okay, this is the Boyle's law illustration. So when you decrease the volume, okay, decreasing volume increase the collision. So it will increase the collision when you decrease the volume. Okay, for example, this one volume is 1 liter, pressure is 100 millimeter mercury. So when you decrease the volume, the collision will increase. The collision of the molecule inside the container will increase. So when collision increase, pressure will increase. So that's why for the Boyle's law, it said that pressure is inversely proportional to the volume. So when we decrease the volume, pressure will increase. So when you plot a graph between the volume and pressure, okay, so you can get this graph. Okay, when you plot pressure versus volume, you can get this graph. So it means that when pressure increase, volume decrease. So when volume decrease, pressure will increase. Okay, so when you plot the graph between pressure versus 1 over volume, you can get the straight line graph. Okay, this is an example of the application of Boyle's law. For example, is breathing and syringe. So in breathing, so we know that when we increase the pressure, okay, so when we inhale the gases, so when pressure increase, the volume will decrease. Or for the syringe, when you press the syringe, so it means that you increase the pressure, so volume will decrease. Okay, this is the example for question for Boyle's law. A sample of chlorine gas occupies a volume of 946 ml at a pressure of 726 millimeter mercury. So what is the pressure of the gas in millimeter mercury if the volume is reduced at constant temperature to 154 ml? Okay, so from this question you can see that there is a volume and pressure. So this volume is volume 1 and this pressure is pressure 1. So from this question, ask you to calculate the pressure. So they ask about to calculate the pressure 2. So this one is V2. You need to label V1, P1, P2, V2. Okay, so just substitute to this formula from the Boyle's law. P1 V1 equal to P2 V2. Just substitute to this formula. So you will get P2 is equal to 4459 millimeter mercury. So this is the answer. Okay, second gas law is Charles' law. For the Charles' law, we fix a number of mole and pressure. But we talk about only for the volume and temperature. So Charles' law said that the volume of a fixed amount of gas is maintained at constant pressure is directly proportional to the absolute temperature of the gas. So volume is directly proportional to the temperature. Okay, volume is directly proportional to the temperature. So it means that when we increase volume, temperature will increase. So when you do the equation, so T you put to the left, so V divided by T equal to K. Okay, so when you have two value of volume and two value for temperature, you can use this equation. Okay, V1 T1 equal to V2 T2. Okay, from here. Dapat daripada sini. Okay, this one because of there is two value of volume and two value of temperature. So this T should be in Kelvin. So if you have the temperature in degrees Celsius, you need to convert to Kelvin. So this is one of the rules. You need to convert the temperature to the Kelvin. Okay, actually there is another law that is Gay-Lussac's law. Actually, it improved from the Charles law. It is another part of the Charles law. That is, it talks about the pressure. This one, it talks about the volume. This one, it talks about the pressure. So, it said that pressure is proportional to the temperature. So, Gay-Lussac law, P1 T1, P1 divided with T1 equal to P2 divided with T2. So this one is Gay-Lussac's law. And this one, so this one V1 over T1 equal to V2 over T2. This one is a Charles law. Okay, this is the illustration for the Charles law. So from this illustration, you can see that when we increase the temperature, okay, this is low temperature. When we increase the temperature to T2, okay, so volume will increase. So that's why volume is proportional to the temperature. So when we increase the temperature, volume will increase. So if you plot a graph for volume versus temperature, so you can get the straight line graph. So from here you can see that when we increase the temperature, volume will increase at pressure constant. Okay, this is the example of the Charles law. Okay, so it means that here, when you decrease the temperature, so volume will decrease. Okay, kemek lah ni. Or for the balloons, air balloons, here, when you increase the temperature, so volume inside the balloon will increase. Temperature increase, volume also increase. Okay, this is an example for the Charles law. A 1-liter steel tank is fitted with a safety valve that opens if internal pressure exceeds 1 times 10 power 3 torr. Okay, so valve will open if it exceeds 1 times 10 power 3 torr. It is filled with helium at 23 degrees Celsius and 0.991 atm and placed in boiling water at exactly 100 degrees Celsius. So will the safety valve open? So from here you can see that you need to calculate the pressure. So if the pressure exceeds this value, so it means that the safety valve will open. So here you can use this formula, P1 over T1 equal to P2 divided by T2. So just use this formula. So pressure here is 0.991 atm for the P1. Temperature 1 is 23 degrees Celsius. But this one you need to change to Kelvin. Can you tukar Kelvin? So this one is P2. So you need to calculate P2. And temperature for 2 is 100 degrees Celsius. So you also need to change to Kelvin. Okay. Please change all these two values to Kelvin. So P2, so just substitute all the value to this formula. P2 you'll get 94898 torr. The answer should be in ATM because this one is NTM. But you need to convert to torr. So when you convert to torr, you will get 948.98 torr. So the safety valve will not open. Tak buka. Why? Because the P2 here, the calculated P2 is less than 1 times 0 times 1.0 times 10 power 3 torr. So the safety valve will not open. Okay, this is another law, that is Avogadro's law. So Avogadro's law said that at constant temperature and pressure, the volume of a gas is directly proportional to the number of mole of the gas present. Okay, so at fixed pressure and temperature, volume is proportional to the N, number of mole of gas. So N here you can put to the left side, so equal, so V over N equal to K. So here we have V over N. So when you have two value of V and two value of N, you can use this formula. Okay, so this is the main formula, that is V1 divided by N1 equal to V2 divided by N2. Okay, so this is the formula for the Avogadro's law. Okay, this is the example, the application of Avogadro's law. That is inflating a balloon and breathing. So it means that when volume increase, number of mole will increase. Okay, this is an example for the Avogadro's law. A scale model of a beam rise when it is filled with helium to a volume of 55 dm cube. When 1.1 mole of helium is added to the beam, the volume is 26.2 dm cube. So how many more grams of helium must be added to make it rise? So assume temperature, assume constant temperature and pressure. So this one you need to use this Avogadro's law, V1 over N1 equal to V2 over N2, because it's a constant temperature and pressure. So just substitute all the value to this formula. Okay, you will get N2 equal to 2.3 mole. But the question asks you about additional amount of helium needed, additional grams of the helium needed to make it rise. So it means that 2.3 mole you need to subtract with 1.1 mole. So equal to 1.21 mole helium. So from here you can calculate the mass by multiply with RMM of the helium. So 4.84 gram. Okay, so this is the mass of the helium. Okay, now we go to ideal gas equation. Okay, this is the ideal gas equation. That is PV equal to nRT. Okay, so this is his ideal gas equation, PV equal to nRT. So this is very, very important equation. So you need to remember this equation. So actually PV equal to nRT comes from gas law. That is Boyle's law, Charles' law, and Avogadro's law. So we get this one from these three law. So for example, from Boyle's law, we know that Boyle's law, the equation is PV equal to K. So here, PV equal to K because of the Boyle's law. And then Charles' law. Charles' law is V divided by T equal to K. V divided by T equal to K. So this one comes from Charles' law. And then for the Avogadro's law is V divided by N. V divided by N. So when we combine the Boyle's law, Charles' law, and Avogadro's law, we'll get PV equal to nRT. So this is the ideal gas equation. So PV equal to nRT, the ideal gas equation, there is R. R here is a gas constant. Okay, R is a gas constant. So gas constant, universal gas constant, you can use all these unit actually. Okay, but we focus on this one, this unit, because we have for this unit 0.082057 is in liter ATM K minus 1 mole minus 1. So you can use this R gas constant, or you can use this gas constant 8.314472 liter kilopascal K minus 1 mole minus 1. Okay, so you can use this gas constant. Because this gas constant, there is a liter, ATM, Kelvin and mole. Okay, or liter, kilopascal, Kelvin or mole. So you can use these two value of the gas constant. Nak guna mana-mana pun boleh, tapi sebenarnya yang ini lebih sesuai lah. Because ada liter, ATM, K minus 1, mole minus 1. Okay, standard temperature and pressure, STP. So standard and temperature and pressure, so this one is standard. Standard. So standard is in 0 degrees Celsius. Standard temperature is in 0 degrees Celsius. 273.15 Kelvin. Okay. Room temperature, that one is not standard. That one is room temperature, 25 degrees Celsius. So when we talk about the standard temperature is 0 degrees Celsius, 273.15 Kelvin. Standard pressure is 1 atm. You need to remember, standard pressure 1 atm or 760 torr. So this is all the conversion. 1 atm is equal to 760 torr equal to 760 millimeter mercury equal to 101325 pascal or 101325 kilopascal. Sama. This one all sama. Cuma convert sahaja. So at STP, 1 mole of any ideal gas has a volume of 22.42 liter. At standard temperature and pressure. This one is short form for the standard temperature and pressure. That is STP. So 1 mole of ideal gas, the volume is 22.4 liter, 42 liter. Okay, this is an example. So what is the volume in liters occupied by 49.8 gram of hydrochloric acid at standard temperature and pressure? So we know that at standard temperature and pressure, temperature should be 0 degrees Celsius. That is 273.15 Kelvin. And then pressure at standard pressure is 1 atm. So you can use PV equal to nRT, the ideal gas equation, to calculate the volume. Okay, to calculate the volume, you can use PV equal to nRT. So PV equal to nRT, volume equal to nRT over P. R here, the gas constant. So you should use 0.0821 liter ATM mole minus 1 K minus 1. Banyak kan ada gas constant terus kan? So guna value this one. Kenapa? Because in this value there is a atmosphere, ATM. There is a mole, there is a Kelvin and liter. So you can find liter. Kena guna yang ini. Jangan guna gas constant yang lain sebab gas constant ini ada liter. Okay. And then mole. And here is a mole. So you need to calculate number of mole from 49.8 gram. So 49.8 gram multiply with RMM. Divide with RMM. RMM for the hydrochloric acid, that is 36.45 gram hydrochloric acid. So you get number of mole, okay, for the hydrochloric acid. So you can substitute to this one. And then temperature to 73.15 Kelvin, because standard temperature and pressure, temperature should be 0 degrees Celsius. And pressure should be in 1 atm. So just substitute all the information into this one, this formula. So you'll get volume in liter. Okay, because all the unit you already cancel here, you'll get answer should be in liter. 30.7 liter. Okay, next example. Argon is an inert gas used in a light bulb to retard the vaporization of the filament. A certain light bulb containing argon at 1.2 atm and 18 degrees Celsius is heated to 85 degrees Celsius at constant volume. So here is given, here is constant volume. So volume are constant. R is a constant. R semua sama kan? R is a constant. So what is the final pressure of argon in the light bulb in atm? Okay. So because this one in a closed container in a light bulb, so N also are constant. So PV equal to nRT. So this is the ideal gas equation. So because nR over P is a constant, so P equal P divided by T. So use this one, P equal P divided by T. So just use this one, P1 over T1 equal to P2 divided by T2, because all the N, V dan R is a constant value. So you can find P2, the final pressure for P2. So just substitute all the information to this formula. So lastly, you will get 1.48 atm. So this is the answer. Okay, now we go to the density and molar mass. Okay, this is the formula for the density and molar mass. Okay, so M here is a molar mass, equal to density, D is a density, multiply with R is a gas constant, temperature, divided by P. Okay, so this is the formula, molar mass, when we want to calculate the molar mass. Or you can rearrange this equation, you will get density equal to molar mass, multiply with pressure, divide with R is a gas constant, and T is a temperature. So from here, you can see that the density of a gas actually is directly proportional to the molar mass. Okay, so when density is increased, molar mass also increase. Okay, from this equation actually is actually derived from the ideal gas equation. Sebenarnya dapat daripada ideal gas equation, that is PV equal to nRT. So PV equal to nRT. So to get this equation, so N here is a number of mole, right? So number of mole equal to mass divided with molar mass. So this is the basic formula. Mass divided with molar mass is a number of mole. So when this N, you substitute with M divided by M, so you get this one. PV equal to M divided by M. M here is a mass, M here is a molar mass, RT. Okay, so from here, actually, M over V is density. Okay, M over V is a density. So when you rearrange this one, M over V here, you will get PM divided with RT. P is a pressure, multiply with M is a molar mass, divided with RT. So that's why density actually is a molar mass, multiply with pressure. Okay, same here. R is a gas constant, divided by multiply with T. So D equal to PM over RT. Or if you rearrange this one, you will get M equal to dRT over P. Okay, so this is the two formula that you need to remember to calculate the molar mass or to calculate the density. Okay, this is the example to calculate the molar mass of the gas. A 2 0.1 liter vessel contains 4.65 gram of a gas at 1 atm and 27 degrees Celsius. So what is the molar mass of the gas? So we want to calculate the molar mass. Okay, so molar mass equal to density multiply with gas constant multiply with temperature multiply with pressure. Okay, so density. So density you can calculate from 4.65 gram divided with 2.10 liter. So you get density 2 to 1 gram per liter. Okay, so this one, gram per liter. R here is a gas constant. You need to use this R gas constant 0.0821 liter atm per mole Kelvin. Cannot use 8.341. This one cannot be used. You need to use this value of the gas constant. And then multiply with temperature. 300.15 Kelvin. 315 Kelvin. Okay, this is temperature from here, 27 degrees Celsius. And then divide with pressure. Pressure is 1 atm. So just solve this all the formula. Okay, you can cancel all the unit. So molar mass is equal to 54.5 gram per mole. So this is the answer for the molar mass of the gas. Okay, now we go to gas stoichiometry. Ini sama saja yang pernah belajar pasal stoichiometry sebelum ini. So when the reactants and or products are gases, we can also use the relationship between the amount, moles and volume V to solve the problem. Okay, so you can use the relationship between moles, volume to solve the problem, to solve the stoichiometric problems. Okay, I give an example here. What is the volume of gas CO2 produced at 37 degrees Celsius and 1 atm when 5.6 gram of glucose are used up in the reaction? So here we want to find gas CO2, volume for the CO2. But given here is a mass of the glucose. So you can use this mass of the glucose to find the carbon dioxide, volume of the carbon dioxide. So it means that you need to find number of mole here. And then use the mole ratio to find this number of mole. Okay. So 5.6 gram divide with RMM for the glucose, you get number of mole for the glucose. And then use the mole ratio. Okay, this one 1 mole of gas is equal to 6 mole of CO2. So use the mole ratio, then you will get number of mole of CO2. So 0.187 mole of CO2. Ni kena tengok balik stoichiometric yang kita belajar dulu. Okay, tak cari mole. And then if you calculate the number of moles, so you can calculate the volume. So you just use PV equal to nRT. So volume equal to nRT over P. And then substitute all the information to this equation. And here is a 0.187 mole. R here is a gas constant. And then this one, temperature is from the 37 degrees Celsius. You need to change to Kelvin. Kenapa kena tukar? Kerana R is a gas constant in Kelvin. And then divide with pressure. Pressure is 1 atm. Okay, from here. 1 atm. So the answer is, okay, so you can cancel all the unit, the same unit. So the answer is 4.76 liter. Okay, next example. What volume of H2 at 765 torr and 225 degrees Celsius is needed to reduce 35.5 gram of copper to oxide to form pure water, to form pure copper and water. So given here in this question is copper to oxide, the mass. But we want to find volume of the H2 gas. So you can use PV equal to nRT. PV equal to nRT, but you need to find a number of mole for helium. Kena cari number of mole of helium. You can find this number of mole of helium from the copper oxide, mass of the copper oxide. So you can use the stoichiometry. So mass of the copper oxide divide with RMM for the copper oxide, so you'll get number of mole of copper oxide. Then use the mole ratio here, 1:1 here, okay, to get the number of mole for the hydrogen gas. Okay, so N here is from the mole of the hydrogen gas. R here is a gas constant. T is a temperature. Temperature that is 2 to 5 degrees Celsius. You need to change to Kelvin. And then pressure is 1.01 atm. You need to change to NTM from 765 torr to ATM because the gas constant in ATM. Okay, from here you can see that the gas constant in ATM. So you need to cancel the unit. So you need to change the torr to ATM. So the answer is 18.1 liter. Okay, now we go to the Dalton law and Graham's law. Okay, the Dalton's law said that the total pressure of a mixture of gases is just the sum of the pressure that each gas will exert if it were present alone. Okay, for example, here, if you want to calculate the pressure total, this one, inside here there is air. Actually, this air is a combination of oxygen, nitrogen gas, argon, or all the gas. Okay, so this pressure of air actually, okay, according to the Dalton's law, this pressure of gases actually is a pressure of the oxygen plus pressure of the nitrogen gas, argon, H2O, and CO2. Just all the summation of the pressure, types of pressure inside the air. Okay, so P total equal to P1 plus P2 plus P3 plus P4 and etc. etc. Okay, for example here, okay, gas A, if you calculate the pressure for the gas A is 300 millimeter mercury. Okay, you can calculate using this height of this tube. For gas B, for example, pressure is 400 millimeter mercury. So when you have the combination of gas A and gas B, so if you want to calculate the pressure, actually this pressure actually is a summation of the pressure for A and pressure for B. So that's why this gas AB, the pressure is 700 millimeter mercury. Okay, now we go to the mole fraction. Actually, the partial pressure for each element inside the container, it depends on the mole fraction. Okay, the partial pressure actually depends on the mole fraction. The mole fraction X is a ratio of the number of mole at one component to the number of mole of all components present. So in general, the mole fraction of component A in a mixture is given by, so mole fraction of component A is equal to number of mole for substance A divided with total number of mole. For example, if I have A and B, so divide with Na plus Nb. So mole fraction is equal to Na divided by N total. So Na here is number of mole. So to calculate the partial pressure, to express the partial pressure, when you use mole fraction, so partial pressure for A equal to XA is a mole fraction for A multiply with pressure total. Okay. So pressure for A equal to mole fraction for A multiply with pressure total. Okay, I give an example here. A sample of natural gas contains 824 moles of CH4. Okay. 0.421 moles of C2H6 and 0.116 mole of C3H8. If the total pressure of the gases is 1.37 atm, so what is the partial pressure of propane, C3H8? So in this question, they ask about the partial pressure of the propane. And given here, number of mole for propane, number of mole for C2H6, and number of mole of CH4. So to calculate this one, you can use this formula. Okay, partial pressure for propane equal to mole fraction for the propane multiply with total partial pressure. Okay, total partial pressure is given in the question, that is 1.37 atm. So mole fraction for the propane, you can calculate from this number of mole. So that is 0.116 mole of propane. Okay, kena letak kat atas. Divide with total number of mole. So total number of mole is 28.24 moles plus 0.421 moles plus 0.116 mole. And then you will get mole fraction for the propane, that is 0.0312. So to calculate the partial pressure for the propane equal to X propane, that is 0.132 multiply with 1.37 atm. You will get 0.0181 atm. Okay, please try this exercise. Okay, and also this exercise. Okay, please try these two exercise. Okay, Graham's law of diffusion and effusion. So actually, Graham's law, it talks about the diffusion and effusion. So this effusion and diffusion is actually a phenomena based on the gases motion. So what is effusion and diffusion? So effusion is the process by which a gas escapes from its container through a tiny hole into an evacuated space. So this is an example of effusion. So effusion actually is a process, okay, which gas, okay, for example, we have a gas inside the container at the left side here. It escaped from a tiny hole. It escaped from the tiny hole to the evacuated space, to this space. So the gas is escaped only in the tiny hole. But for the diffusion, it's the process of gas movement of one gas through another. So for example, I have the gas molecule in the left container. Then I open this partition. So the gas will move from this side to another side. From this side to this side. So this process is diffusion. Okay. So effusion, when there is a tiny hole, but diffusion is a movement from the gas molecule from one side to the another side. Okay, rate of fusion. So the rate of effusion of a gas is inversely proportional to the square root of its molar mass. Okay, so the rate of effusion actually is inversely proportional. For example, Graham's law of effusion time A. This one A. So it's inversely proportional to the square root of the molar mass. Square root of the molar mass. Okay, so time B is equal to square root of the molar mass of B. So rate of effusion is inversely proportional to 1 over square root M. Rate of effusion is inversely proportional to 1 over square root M. So time A divide with time B equal to square root MA divided by square root MB. Or rate A divided by rate B equal to square root for the MA divided by square root for the MB. Okay, please, you can try this exercise. Okay, deviation from ideal behavior. Kinetic molecular theory postulate. So postulate of the kinetic molecular theory. Kinetic molecular theory explains the law that describes the behavior of gases in which it was developed during the 19th century. So, kinetic molecular theory of gases is provide a molecular explanation for the observation that lead the development of the ideal gas law. So, this is the kinetic molecular theory. Okay, for the first one, the theory is said that gas consists of tiny particles of negligible volume. Okay, so gas, it have a tiny particle. Intermolecular forces of attraction do not exist between the gas particle. So there is no attraction between the particles. So gas are in continuous random motion. So gas in random motion, and the gas particle are perfectly elastic. Okay, it is elastic. And lastly, the average kinetic energy of a gas is proportional to the absolute temperature. So all here is a postulate for the kinetic molecular theory. However, there is a deviation from the ideal gas behavior. There is a deviation from the kinetic molecular theory postulate. So, deviation of the ideal gas behavior, it happens at two conditions only. For another condition is still in ideal gas behavior. But if there is if there is a two condition, these two condition, the ideal gas will deviate. The properties, the behavior will deviate. That is when it is in high pressure or in low temperature. So when in this condition, it will deviate from the ideal gas behavior. So at this condition, the gas behave a real gas rather than ideal gas. So under this condition, the basic two assumption behind the ideal gas law, namely the gas molecule have negligible volume and the intermolecular interaction are negligible. Okay, because previously kinetic theory said about the gas molecule have negligible volume, right? But this one you need all the assumption, the kinetic theory is negligible because of this condition. So if you plot a graph for the gases, okay, the ideal gas should be straight line. Okay, this is the ideal gas. However, because there is a deviation because of the high pressure, so the gases deviate from the ideal gas behavior. Okay, so deviate. So this one is a deviation occur. So the curve is different. This is the ideal gas. So the beza lah, dia punya curve dia. So what really happened at this condition at low temperature and high pressure? So high pressure, actually the intermolecular distances become smaller. Okay, so when we increase the pressure, actually we decrease the volume. So the intermolecular distance becomes smaller. So volume occupied by the molecule becomes significant compared to the volume of the container. So total volume occupied by the gas is greater than the volume predicted by the ideal gas law, because we already increased the high volume. Because we know that when we decrease the volume, it is high pressure. Okay, at low temperature, actually the kinetic energy of the gas molecule is decreased. When we decrease the temperature, kinetic energy, kelajuan molekul tu pun berkurang sebab temperature dah rendah. So molecules can no longer overcome to intermolecular attractive force. So the gas liquefies or condense to a liquid when at the low temperature. So what is the ideal gas and real gas? So what is the difference between the ideal gas and real gas? Okay, ideal gas, we use the formula PV equal to nRT. But there is a deviation when at high temperature and low temperature. High pressure and low temperature. So it can deviate from the behavior of the ideal gas. It become real gas. So ideal gas actually is volumeless. But the real gas is a finite volumes. Particles do take up space, and volume of the gas is actually less than the volume of the container. Ideal gas actually do not interact with each other, but the real gas is particle interact with each other. Ideal gas molecule will travel in straight line, okay, but real gas paths will curve due to the attraction between the molecules. So there is a difference between the ideal gas and real gas. Okay, that's all for these topics. Thank you, class.